Last minute series 10. This is about variation, especially for the partial variation. Okay, so I will go through 6 examples. This is the first example. Let's see. Let C be the cost of painting a can's of surface area 8 meters square. It's given that C is the sum of two parts. One part is a constant, so K1, and the other part varies as A, so K2A. This is the first condition when A equal to 2, C equal to 62. This is the second condition when A equal to 6, then the cost equal to 74. You are asked to find part A, find the cost of the painting. So you need to find C and a can's of surface area 13 meters square means A equal to 13 meters square. So A equal to 13. You are going to find the values of C. Okay, let's see how to do it. For partial variation, we can see that sum of two parts. Okay, so first of all, let C equal to the two parts, sum of two parts. The first part is K1 plus the second part is K2A, where we need to state K1, K2 are non-zero variation constant. Okay, so after you state it, then when A equal to 2, C equal to 62. So K1 plus K2 times 2. And the second piece of information, C equal to 74, then A equal to 6. K1 plus K2, 6. Okay, we just substitute the values of A and C into the equation we assume. Okay, so the first one and the second one. What's left to solve this simultaneous equation? So we can use the second equation minus the first one. So 74 minus 62, we get 12. And K1 minus K1 becomes 0. Here K2 times 6 means 6K2. K2 times 2 means 2K2. So 6K2 minus 2K2, you can get 4K2. So divided by 4 on both sides, so 12 divided by 4 equal to 3. Therefore, we can get K equal to 3. And then we substitute K2 equal to 3 into the first equation. Then what can we get? 62 equal to K1 plus K2, we got it 3 times 2. So K1 equal to 62 minus 3 times 2 equal to 6. So 62 minus 6, we get 56. 56. So therefore we have the equation C equal to 56 plus 3A. So for part A, when the surface area equal to 13 meters square, then the cost equal to 56 plus 3 times 13 give 56 plus 39, so which is $95. So the cost equal to $95. So what we have for part A is we have the equation 56 plus 3A, and part A's answer, the cost equal to $95. Now let's do part B. Let me erase part A's answers first. Erase it. And then read part B's question. there is a larger can. So let me highlight it, which is similar to the can described in part A. If the volumes of the larger can is 8 times that of the can described in part A, so find the cost of painting the larger can. So in part B, there's a keyword similar. So we know that for similar figures, the ratio between the volumes will equal to the ratio of the corresponding sign to the power 3, and the ratios of area equal to the ratios of corresponding sign to the power 2. So we can combine these two relationships. We will get that for part B, the ratios of the larger can, the volumes of the larger can over the volumes of the smaller can to the power cubic root, then will equal to the ratios of area square root. Okay, for the larger can and the smaller can, which is 8 to 1, the ratio takes cubic root. And larger can's surface area, we don't know, we just let it A1. And the surface area in part A, which is 13, so take square root. So let me let it here, where A1 meter square represent where A1 be the surface area of the can described in part A. Okay, so left hand side, A over 1 is 8, cubic roots of 8, which equal to 2. So right hand side is A1 over 13. So you can take square roots take square on both sides. So you can remove the square root. So left hand side is 4, right hand side square and square root can be removed, so A1 over 13. Therefore A1 equal to 4 times 13, which is 52. So in part A, we got the relationship, the cost equal to 56 plus 3A. Now we have the surface area 52, so the cost 52 plus 3 times 56 plus 3 times 52, which we have 201.56, so $212. Okay, this is the answer for part B. So let's move to next question. Okay, if you already understand these types of question, partial variation, you can jump to the last example, which is direct variation, inverse variation. So if you still don't not get the concepts of partial variation, then please stay on these examples. I will provide you 5 examples on partial variation. Okay, so the second example it is, so let's read the question. The weight of a chase of perimeters L meters, the weight will be W grams. It's given that W is the sum of 2 parts. So you see, when you see sum of 2 parts, then partial variation. The first part varies as L, so varies directly as L, so which is K1L, and the other parts varies directly as L square, so this is K2L square. So and then you have 2 pieces of information. When L equal to 1, the weight W equal to 181, and the perimeter equal to 2, then the weight equal to 402. So for part A, we need to let W be the two parts, right? K1L plus K2L squared. So where K1, K2 not equal to 0, we need to state this. And then input the two pieces of information when L equal to 1, W equal to 181. So K1 times 1 plus K2 times 1 square. So which can be simplified as 1A1 equal to K1 times 1, which is still K1, and plus K2 times 1 square, which is still K2. Okay, this is the first equation. And the second part, when L equal to 2, W equal to 402 grams. So K1 times the perimeter is 2 now. So plus K2, perimeter is 2 to the power 2. So we can simplify it as 402 equal to 2K1 plus 2 squared, which is 4, so 4K2. Because the three numbers here, 402, 2, and 4 are all the multiples of 2, so we can divide it by 2 for the whole equation. Then we can simplify it as 201 equal to 2K1 divided by 2, which is K1, 4K2 divided by 2, which is 2K2. So this equation 1, this is equation 2. Now you can use equation 2 subtract equation 1. So 201 minus 181, which is give you 20 on the left hand side. Right hand side, which is K1 minus K1, which is 0. 2K2 minus 1K2, which is 1K2. So therefore K2 equal to 20. Now you can substitute K2 equal to 20 into the first one. Is more simple. So we have 181 equal to K1 plus K2. K2 is 20 now. So K1 equal to 181 minus 20. So it's 161. Therefore, we have the relationship W equal to 161 plus times L plus K2 equal to 20, so 20 times L squared. Okay, this is the equation for the weight and the perimeter. But in part A, you are asked to find the weight of perimeter 1.2 meters. It means that when L equal to 1.2 meters, what is W? So you are asked to find W. Okay, so let me make it smaller. Let me make it zoom in, zoom out, zoom in. Okay, so therefore, let me write here. Therefore, when the perimeter means L is 1.2 meter, then the weight will equal to 161 times 1.2. Let me write it here. Let me erase it. Then the weight equal to 161 times L, 1.2 meter, plus 20 times 1.2 to the power 2. So we can use calculator to get the final answer. So 161 times 1.2 plus 20 times 1.2 to the power 2. So which is the weight is 222 grams. Okay, this is part A's answer. Now let me write it down. The relationship for part A, which is W equal to 161L plus 20L squared, and when L equal to 1.2 meter, then we have the weight equal to 222 grams. Okay, now let's try to do part B. Let me erase part A's answer. Okay, part A's answer here. Let's erase it. So part B, you're asked to find the weight of a shade is 594. Find the perimeter. So what does it mean? If the weight is 594, means W, if W equal to 594 grams, then you need to find the perimeter of the shade. You need to find L. L represent perimeter. Okay, so we starting from the equation, the relationship between the weight and the perimeter, 161L plus 20L squared. So now you have the values of W, 594, so we replace it, and then we just need to find out the values of L. So it means that you need to find out the quadratic formula, quadratic equation. So this 20L squared, this is 161L, which on the right hand side, we move 594 from left to right, so minus 594. So originally we should write zeros here, but I want to make it better presentations here, so I write it on the right hand side. Ax squared plus bx plus c equal to 0. So here, what is L? So we need to factorize it or use quadratic formula. So let me use quadratic formula. L equal to negative b, negative 161, plus or minus square roots of 161 squared minus 4ac, c is negative 594, and divided by 2a. So what can we get? Let's use calculator to solve it. So the first root should be 11/4, or another root. The second root is negative 54/5. Okay, so because L represents the perimeter, for the negative answer, we need to reject it. So therefore, the perimeter of the shade is 11/4 meter, which is 2.75 meters. Okay, that's the end for part B. These examples are just similar as the previous two, but here give you the conditions. The two pieces of information are different. So as you can see it here, the first piece of information give you f2 equal to 59. It means when x equal to 2, then the fx equal to 59. And here give you f7 equal to negative 121, which means x equal to 7, and fx equal to negative 121. So here, let's read the question. It's given that fx is the sum of two parts. One part varies as x squared, which means k1 x squared, and the other part is constant, which means k2. So for part A, we can let fx is the sum of two parts. One is k1 x squared, another one is constant k2. So you need to state that k1, k2 not equal to 0, non-zero variation constant. Okay, so and then use the two pieces of information. When x equal to 2, so f2 equal to k1 times 2 to the power 2 plus k2, so which is 59. So you can simplify it as k1 times 2 to the power 2, which is 4k1, and then k2 equal to 59. Okay, so the second piece of information, which is f7 equal to negative 121. So f7 just means that you substitute x equal to 7 and so which is k1 7 to the power 2 plus k2, so give you negative 121. So we can simplify it as 7 to the power 2, which is 49 times k1 plus k2, so equal to negative 121. So we call this equation 1, this equation 2. Then we can solve this simultaneous equation by just subtract 1 from 2. Okay, 2 minus 1, we get 49k1 minus 4k1, which is 45k1. k2 minus k2, which is 0. Right hand side negative 121 minus 59, so will be negative 180. So divided by 45 on both sides, we get negative 180 divided by 45, which is negative 4. So after we have k1, we can substitute k1 equal to negative 4 into equation 1. Then we have, which is 4 times negative 4 plus k2 equal to 59. So k2 equal to 59. This part is negative 16, so move it to the right hand side, become positive. So 59 plus 16, so which is 75. So therefore we have fx equal to k1 is negative 4x squared plus k2 is 75. So we are going to find out f6. Therefore when x equal to 6, negative 4 times 6 squared plus 75 equal to 24 times 36 times negative 4. We can use calculator. Okay, negative 4 times 36 plus 75, so we have negative 69. So part A's answer, f6 equal to negative 69. Okay, so let me write down. fx equal to negative 4x squared plus 75. So we have f6 equal to negative 69. Okay, after finish part A, let's continue part B. Let me erase all the things, all the solution for part A here. Leave some space for part B. So let's read part B first. Okay, so part B, point B are the points lying on the graph y equal to fx. So this is a parabola. As you can see in part A, fx equal to negative 4x squared plus 75. So you are asked to find the areas of triangle ABC where C is a point lying on the x-axis. So for this part, we must need to know the situation. So we need to draw the graph. So we need to know how to draw the graph, okay? So fx equal to negative 4x squared plus 75. Because negative 4 is smaller than 0, so this parabola open downwards. And we need to check delta b squared minus 4ac. So let me write here for delta equal to b squared. B is 0 because we do not have the term x. B squared minus 4ac, so which will become positive, bigger than 0. So the parabola must cut the x-axis at 2 points, okay, 2 distinct points, and open downwards. So parabola must go downwards and cut it in this way. Okay, this is y equal to fx. And now we can see that 1 is 6a, negative 6b. So 6 and negative 6. And what is the axis of symmetry? So we also need to know the axis of symmetry for this parabola. So this is the axis of symmetry. So how to find this equation? We know that axis of symmetry should be equal to x equal to negative b over 2a. So b equal to 0, so this also equal to 0. So x equal to 0 should be the y-axis. So it means that the parabola is symmetric about the y-axis. So when you have one point A, the x-coordinate is 6, and the point B, the x-coordinate is negative 6, so must be symmetric, these 2 points. So let me assume, I don't know whether, because symmetric, the x-coordinates of A and B is symmetric about the y-axis. So the values of A and B, A is here, B is here, must be the same. A must equal to B, okay? A must equal to B. But we don't know the values of A or B. Okay, so let me assume negative 6 and 6. Okay, we can find out the x-intercepts first. How to find the x-intercepts? We need to put y equal to 0, right? When y equal to 0, then negative 4x squared plus 75 equal to 0. So we have 75 equal to 4x squared. So 75 over 4 equal to x squared. So x must be positive or negative square roots of 75 over square roots of 4, which equal to 2. So 75, so let me use calculator to get the approximate values of square root 75 divided by 2. So this one should be negative 4 point something, 4.333330127019. Okay, you just has the approximate values, and this one should be positive 4.33 something. Okay, so we don't need to know the exact value, because I just want to know that where's negative 6 and positive 6. So must not within this 2 points, okay? Must be on this 2 points, be on this range. So we know that point A and point B should be here. Okay, let me assume this is straight line, cut it at point B, which is -6b, and this point A, positive 6a. Okay, so you see y equal to a or y equal to b. So this is a straight line because a equal to b. So if you get the values of a, then you get the values of b. Then this straight line, the blue horizontal line, should be y equal to a. Okay, so after that, and point C is a point lying on the x-axis. So because we know that the distance, for example, let me just choose a point, any points here. Okay, let me choose a point here, point C, right? Okay, triangles ABC, this red triangle. Actually, no matter where's point C, the base is AB. The base is AB, and we got 6 minus -6 equal to 12. So AB equal to 12, and the height, no matter which point C it is, the height is the distance between x-axis and this line. Okay, so we can get the values of A and B easily because point A and point B lies on the parabola. So we can find it when x equal to 6. Let me just use 6. Okay, f6 will equal to 8. So f6, which is -4 times 6 to the power 2 plus 75. So 36, 144 plus 75. This is negative, so -25, -69. So this is -69. Therefore, A equal to B equal to -69. So the distance between the x-axis and the straight line y equal to -69, which is 69. So I just write down the height of the triangle. The height of triangle ABC just equal to 69. Okay, so area of triangle ABC equal to base. Base is AB times the height divided by 2. So AB, we get it 6 minus -6. This is the base times the height. The height is 69 divided by 2. So we get 69 times 12 over 2, which is 69 times 6, which is 414. So this is the area of the triangle ABC. That's it for part B. Okay, let's move to the fourth example. When Suzanne sells an handbag in a month, her income in that month will be $. It's given that S is a sum of two parts. You see, two parts, sum of two parts. One part is a constant, so this is K1, and the other part varies as n, which is K2n. So the first piece of information, when n equal to 10, S equal to 10,600. And the second piece of information, which is n equal to 6, then S equal to 9,000. So for part A, we can net S is a sum of two parts. Net S equal to K1 plus K2n. So we need to specify K1, K2, K1, K2 not equal to 0. So we put n equal to 10, so K1 plus K2 times 10 equal to the values of S, which is 10,600. And then this is the equation 1. And equation 2, when n equal to 6, so k1 plus k2 times 6, s equal to 9,000. So this is equation 2. So we can simply use equation 1 minus equation 2. So we get 10,000 minus 9,000 equal to 1,000. So 10,600 minus 9,000, we can have 1,600. K1 minus K1, which is 0. 10K2 minus 6K2, which equal to 4K2. So K2 divided by 4 on both sides. So 1,600 divided by 4, which equal to 400. So we get K1. Okay, after we get K1, then substitute we get K2, substitute K2 equal to 400 into equation 2, which is the number which is smaller. So we have 9,000 equal to K1 plus K2 equal to 400 times 6. 400 times 6, which is 2,400. 2,400, and then so 9,000 equal to K1 plus 2,400. So minus 2,400 on both sides. So K1 equal to 9,000 minus 2,400, which is 6,600. So this is K1. So therefore, we have the equation s equal to K1 6,600 plus K2 400 times n. Okay, 400 times n. Now, part A asks, when Suzanne sells 20 handbags in a month, so it means when n equal to 20, find her income. So you need to find the values of s. So when n equal to 20, then the income, her income equal to 6,600 plus 400 times 20. So which is 8,000. 6,600 plus 8,000, which is 14,600. Okay, so this is her income, part A's answer. Okay, now after part A, then we move to part B. Let me just copy down the relationship. S equal to 6,600 plus 400n, and in part A, when n equal to 20, then s will be $14,600. Okay, the income. Now let me erase this part and leave some space for part B, so you can read part B's question first. So let's see part B. Is it possible that when Suzanne sells a certain numbers of handbags in a month, her income in that month is 18,000? Is it possible? So explain your answer. Okay, so let's see. Let for part B, we can let s equal to $18,000. So we try to see whether we can get the values of n. So 18,000 equal to, because s, let me write down the relationship for s and n. So because s equal to 6,600 plus 400n, that's what we get in part A. So now when s equal to 18,000, we just substitute. We can substitute, okay? We can substitute s equal to 18,000 into s equal to 6,600 plus 400n. Okay, we can substitute it, so we can change this one equal to 18,000. Okay, try to solve it. So 18,000 minus 6,600, move it to the left, move the number to the left, so we get 400n. So left hand side should be 11400, okay, equal to 400n, and then n equal to 11400 over 400. So what can we get? 11400 divided by 400, so we get 28.5. Do we have 28.5 handbags? So the numbers of handbags must be integers. So this one is not, which is not an integer, positive integer. Therefore, it is impossible for Suzanne to get $18,000. Okay, that's it. So this fifth example, which quite similar to the, I think, to the second example. So let me just show to you here quickly. For part A, because f(x) is sum of two parts, one part varies as x, which is k1x, and the second part varies as x squared, which is k2x squared. So we can net f(x) equal to k1x plus k2x squared, where k1, k2 not equal to 0. Okay, so the first piece of information, f3 equal to, when x equal to 3, so k2 times 3 squared equal to 48. So this can be simplified as 3k1 plus 9k2 equal to 48, and can be divided by 3. So 3k1 divided by 3, which is k1, 9k2 divided by 3, which is 3k2, 48 divided by 3, which is 16. So this is equation 1. And then equation 2, f9 equal to, when x equal to 9, k1 times 9 plus k2 times 9 squared equal to 198. So this can be simplified as 9k1 plus 81k2 equal to 198, which can be simplified divided by 9 for each term. 9k1 divided by 9, which is k1. 81k2 divided by y, which is 9k2. So 198 divided by 9, which is 222. So this is equation 2. Now we can simply use equation 2 minus equation 1. k1 minus k1 will be 0. 9k2 minus 3k2, which will be 6k2. 22 minus 16, which gives you 6. So k2 equal to 6 divided by 6, which is 1. After we have the values of k2, we can substitute k2 equal to 1 into the first equation. So we have k1 plus 3 times k2, which is 1 equal to 16. So k1 equal to 3 times 1 is 3, 16 minus 3, which is 13. Okay, after we have 13 k1, so we will have, let me move it up and make it smaller. Okay, after we have k1, k2, therefore we have the function f(x) equal to k1x, which is 13x, plus k2x, which is 1x squared, just x squared. Okay, so this part is answer. So let me write it down here. f(x) equal to 13x plus x squared. Now let's move to part B. Let me erase this to get some space. Okay, so for part B, what we need to do is fx equal to 90. So fx, we got it from part A, 13x plus x squared. So this fx equal to 90. So we can change it into the general form of quadratic equation. So x squared plus 13x minus 90 equal to 0. So this can be 90. 90 can be separated into, let me see how to factorize this part. 90, let me do short division. 90 divided by 2, 45. 45 divided by 3, which is 15. So 15 divided by 3, which get 5. So we have 18. Yeah, this 2 times 3 times 3 give you 18. 18 and 5, the difference should be 13. Okay, so we get it, which is x plus 18 times x minus 5. So we get 0. So actually I do a draft here to let you understand more. So we can get positive 18, negative 5 for 90. So x times x, so which is 18x. This is negative 5x. So you add them up, this two terms, you get 13x, which is similar, which is exactly the same as the middle term. So we can factorize it as x plus 18 times x minus 5. Okay, so what we get is x equal to negative 18 or x equal to positive 5. So yeah, that's it. Now let's see the final examples. This is not partial variation. As you can see it here, y just varies inversely as square roots of x. Inversely just means k over square roots of x. So you can net part A, net y just equal to k over square roots of x, where k not equal to 0. Okay, look at the information. When x equal to 144, y equal to 81. So y equal to 81, then k over square roots of 144. Square roots of 144, which equal to 12. So k just equal to 81 times 12. Just using a calculator, you can get the answer. 81 times 12, which is 972. So therefore we have the equation y equal to 972 divided by square roots of x. So this part A finished. Let's move to part B. If the values of x increase from 144 to 324, so 144 is here, so you get the values of y. Find a change in the values of y. So we just need to find the new values. When x equal to 324, so what we get, y equal to k is 972 divided by square roots of 324. So you just use a calculator. 972 divided by square roots of 324, which is equal to 54. So you see the change in the values of y equal to the new values minus the original values, which is 81. So 54 minus 81, we know that is negative 27. So it means y is decreased by 27. Okay, that's it. This is the end for this topic 10, variation. So in this 6th example, we just mentioned that 2 types of variation. The first, or example 1 to example 5, we're talking about the partial variation. And the second type is the inverse variation. So we have 4 types of variation. We also have the joint variation and the direct variation. So normally in paper 1 just tells you the partial variation and inverse variation. Sometimes you will also be tasked by the topics of joint variation. So if paper 1 tests you this type, then paper 2 will test you another type. So so in paper 1 you are tasked by the partial variation, then the joint variation will be tested in paper 2. So be aware of that. So you also need to know the other 2 variation, not only these 2, partial variation and inverse variation. You also need to know the joint variation and also direct variation. Thank you. This is the end for topic 10.